Okay, so this is just going to be a brief introduction into section 2.3, which is kind of extending off what we've already done um, with proportions. But we're going to be using proportions and a little technique called dimensional analysis to basically change units, okay? There's a lot of times when we want to be able to translate between units. So one of the examples I think about is I had a recipe that was written by my brother-in-law who's from Norway for Norwegian waffles. And all of the measurements were different measurements. Some of them were weights, and I needed them to be volumes, which can be tricky and kind of hard to convert and yada, yada, yada. But I used this to be able to translate the recipe into something that I could actually use. So that's one very small example. Of course, you go to a lot of other countries and might use the metric system. And so being able to translate between units is pretty valuable and definitely a skill that you're going to use a lot in science classes. So if you could master this skill, that's really going to help you if you want to study any sort of science, especially chemistry, physics. So this is a nice thing to know. So I want to show you an example of how a proportion might go, and I'll just give you an example. So one thing we know, and you may not know this, and that's fine, is that 1 inch is about 2.54 centimeters. Okay, so we know that that's true. And so a question that you could ask, is basically how many centimeters is 25 inches? And you might be thinking, well, Alvin, I could just multiply 25 by 2.54 and bada bing, bada boom, I've got the number of centimeters. And you're right. You're totally right. And another way to do it, so that's a good thing. You just say, well, I could just multiply. Another way to do it is to actually set up a proportion and say, great, let us write a proportion. And remember my tip about how, you got to have units here and units here. Let's call this units B, units A, and they have to match units B and units A. So if you're going to write a proportion, you got to make sure those units match. So for instance, since I know that 1 inch is equal to 2.54 centimeters, I can write a proportion and say, I've got 25 inches, and I want that to be how many centimeters? Okay, so just writing a proportion, and then, I can solve it in the normal way. So maybe 1 over 2.54 is equal to 25 over x. So I'm just dropping the units to declutter a little bit after I've made sure my proportion is set up correctly. And then I might suggest, again, using that cross products property. And sure enough, you will end up with x times 1, x times 1 right there, is equal to 25 times 2.54. And that's going to be in centimeters, and you could find what that number is. It's probably, I don't know, let's see, 25 times 2 is 50, and 25 times 0.54 is probably about 13. So I'm guessing that it's around 63 centimeters, maybe. That would be my guess. Okay, so that is using a proportion basically to change measurement systems. Now, dimensional analysis is something that's kind of interesting, where you basically multiply by fractions that are equal to 1. Okay, so let's talk a little bit here about what we call dimensional analysis, which is something that you are going to use in your classes with, Grace and Nicole and Bob and, many of our science teachers that teach things like chemistry, and Laura, chemistry and physics. So dimensional analysis, I think that's how you spell analysis. And so basically what we need to know is that there are a lot of fractions that equal 1. So let me give you some examples. 12 inches divided by 1 foot. That fraction is equal to 1 because 12 inches is the same thing as 1 foot, which we probably know. Another example would be what we just talked about, 2.54 centimeters divided by 1 inch. That fraction is equal to 1 because 2.54 centimeters is equal to 1 inch. Another one might be, how about 1,000 milliliters divided by 1 liter? That is the same thing. Another thing might be 5,280 feet is the same thing as 1 mile. All of these fractions are equal to 1. And if we flip them, they'll still be equal to 1. 1 inch, 2.54 centimeters, still equal to 1. 1 mile divided by 5,280 feet, that's still equal to 1. 1 liter, 1,000 milliliters here, 1 foot, 12 inches. So these fractions are all equal to 1, all equal to the number 1, because when you divide something by the same thing, you just end up with 1. And so what that means, and what's really important, is that when we multiply by these fractions, we do not change the quantity. We may change the units, but not the quantity. Because when you multiply, something by 1, it just doesn't change it, right? 10 times 1 is 10, 13 times 1 is 13, 26 times 1 is 26. So we can multiply by these fractions and change the units, but not change the quantity. So let me give you an example of what I'm talking about here. So let's say that you had 36 feet and you want to know how many inches. Okay, so the first thing you need is you need your unit conversion, which is a relationship between inches and feet. We want to go from feet to inches. So what we know is that 12 inches is 1 foot. And this fraction right here is, by the way, is equal to 1, right? Because 12 inches and 1 foot are the same thing. So if we take 36 feet and we multiply it by 12 inches over 1 foot, we're not changing the quantity, because remember, this fraction right here is equal to 1. But what happens is the feet divide with the feet, and we're just left with inches. And 36 times 12, well, it's 360 plus 72, which should be 432. So it's 432 inches, if I've done my math correctly. Let me double check that. 36 times 10 is 360. 2 times 36 is 72. 360 plus 72 is 360 plus 72 is 432 inches. Okay, let me give you another example. Say you had 3 meters and you want to know how many inches. I'm having trouble spelling over here. That should be a W. How many inches? Well, I don't know the conversion between inches and meters, but I do know that there are 2.54 centimeters in 1 inch. And I also know that there are 100 centimeters in a meter. So this fraction is equal to 1. This fraction is equal to 1. And because I know these things are true, I should be able to get from 3 meters to 1 inch. So let's add another thing here. So I've got a little bit more space, and let's finish that off. So let's see what we can do here. 3 meters times, okay, so the thing that I want to go down here is meters, because I want the meters to divide. So I know that 1 meter is 100 centimeters, but I didn't want it to be in centimeters. I wanted it to be in inches. So now I've got to get rid of the centimeters. So the centimeters have to go down in the denominator here. I know that 2.54 centimeters is equal to 1 inch. So what I'm left with is 3 times 100 inches divided by 2.54. And so whatever I'm going to end up with there is going to be in inches. Okay, so before we finish this off, and I'm not really sure what that is because I don't have a calculator, but you could find that number. So let's look at two examples. So first we're going to try and write a proportion, and then we're going to try and use a little dimensional analysis. So Jonas drove his car from Montana to Canada on vacation. And while there, he needed to buy gasoline and noticed that it was sold by the liter rather than by the gallon, which is true, perhaps obviously, or maybe not. Use the conversion factor. 1 gallon is equal to approximately 3.79 liters to determine how many liters will fill his 12.5 gallon gas tank. So let us set up a proportion. Okay, so let's see here. We want to have 1 gallon. Okay, sure. We want to have 3.79 liters, right? And over here, we were going to have how many liters will fill his 12.5 gallon tank. So make sure that, again, you've got your units, gallons, matching, liters and liters are matching. And from there, we should be able to solve this proportion, which is 3.79 divided by 1 is equal to x over 12.5. Now we could use the cross products property if we wanted to, which is a good way to solve proportions. Multiply these two, and set them equal. And that will give me x times 1 is equal to 12.5 times 3.79. And so you can find that, and that will be in liters. Okay, so again, we wanted to know how many liters, we know how many gallons, and then on the other side we have liters and gallons, and our units are matching, which is what we want. Okay, of course, another way to do that would be to say, use dimensional analysis. So another way to do it, so let's just say, okay, great, what if we want to do another way? Another way would be to say, well, you know what? 3.79 liters divided by 1 gallon. By the way, this is equal to 1 because these are the same. And so if we have 12.5 gallon tank, you can simply multiply by 3.79 divided by 1 gallon. My gallons will divide, and I'm left with liters. So it should just be, again, 12.5 times 3.79 liters. And so then either way, I get the same thing. So using dimensional analysis on the right in green, and using a proportion on the left in red. Okay, finally, a radio-controlled car traveled 30 feet across the classroom in 1.6 seconds. How fast was it traveling in miles per hour? Oh my goodness. Okay, well, 30 feet, 1.6 seconds. And we want to get to miles and hours. Okay, so the first thing I know is that 5,280 feet is 1 mile. Now let me show you what would happen if I just multiplied this by 5,280 feet divided by 1 mile. Well, the problem is now I have feet times feet. I don't want feet squared divided by miles. I want to get rid of feet and translate this into miles. So we're not going to multiply by 5,280 feet over 1 mile. Instead, we are going to multiply by 1 mile over 5,280 feet, which is also equal to 1, right? Because these are the same thing. Then my feet are going to divide, and I'm left with miles. That's good. If I just left it this way, I would have 30 miles in 1.6 times 5,280 seconds, right? So my units are miles per second now, but I wanted miles per hour, so I got to do some more work. So 30 miles, 1.6 times 5,280 seconds. But now I need to translate these seconds into hours. So because I want to get rid of the seconds, I need to put seconds up here so that I can then divide the two. So I don't know how many seconds are in an hour, but I do know how many seconds are in a minute, and there are 60 of them. So this fraction is now now equal to 1. And so now instead of having miles per second, I have miles per minute, but I didn't want miles per minute. I wanted miles per hour. So I know that there are 60 minutes in 1 hour. Then my minutes will divide and I'm left with 30 miles per hour. Well, not 30 miles per hour, but rather than 30 times 60 times 60 divided by 1.6 times 5,280 miles per hour. So basically I'll end up with 30 times 60 times 60 divided by 1.6 times 5,280 miles per hour. And so then you would need to simplify that. But basically what I'm doing is I'm finding the units that I want to change and then multiplying by a fraction that is equal to 1 to change the units, but not the quantity. So hopefully that gives you a little bit of a start on what we want to do with section 2.3, and we will practice that on Monday. Okay, I think that's it, and I will see you soon.